Now we have the topic trigonometric functions of sum and difference of two angles, means sum and difference of compound angles. What is the meaning of compound angles? So sum of two or more angles is called compound angle. So now we will first derive the first trigonometric identity. We have good number of trigonometric identities. So the first one, from here all the other trigonometric identities are to be derived. So first one is cos x plus y is equal to cos x cos y minus sin x sin y. This derivation is to be done using a unit circle. So cos a plus b is cos a cos b minus sin a into sin b. So we are going to derive this. So for that derivation we want a unit circle. So before unit circle derivation, here how the point, this is a unit circle, means what? Radius of the circle is 1 unit. Distance between center to any point on the circle is 1 unit, that is radius of the circle. So we will locate points on this circle. To locate the points, either we can locate them algebraic mode or the polar form, means trigonometric form. How to represent a coordinate in trigonometric form? For that, just consider this right angle triangle. This right angle triangle we will come across in this diagram a good number of times. So this is the center of the circle and this is radius of the circle. That means center up to point on the circle, and this is also a point on the circle. Since it is a unit circle, this distance is 1 unit. Assume that the base is some a units and height means something on y coordinate, y axis. So that is a b unit. So distance on x axis and distance on y axis, that is how we write any coordinate. X comma y means here a comma b. But we want to write a and b in terms of trigonometric ratio. So how to do that? So for that we want a and b values. So here you see theta. In that case, what is cos theta? Cos theta is adjacent to hypotenuse. Hypotenuse is unit circle radius. So adjacent by 1. So a is actually cos theta. Then we will write sin theta. What is sin theta? Sin theta is opposite to hypotenuse, means a b by 1. So the point on the circle can be written as a comma b, and in trigonometric form can be written as a means cos theta comma b means sin theta. Consider a point P on x axis, and since it is unit circle, the radius is 1 unit. And this point is on x axis, so its coordinate is 1 comma 0, and we will call this point as P1. And then this is the initial ray. Now with respect to initial ray, there is another terminal ray that is turning in anti-clockwise direction. So there is another point P2. So this point is P subscript 2. So I am joining P2 to the center, and this angle is angle A. So as I discussed how to represent a point in trigonometric form, so in that case P2, this is P2, just see that this is visible properly. It is cos of theta, means angle form. So cos of A comma sin of A. So P2 is cos A comma sin A. Sin A. Now this is further rotated through an angle B, capital letter B, and this point is a P3. Now we should write coordinates for P3. How to write coordinates for P3? See, initial ray is OP1, and then the rotation of the ray went up to this, and we got OP3. So the total angle here is angle A plus angle B. So coordinates of P3 is, first cos comes, cos of the total angle, cos of A plus B, comma, sin comes next, sin of A plus B. So this is coordinate of point P3. Then this time, this is the initial ray. Before also this one initial ray, but this time instead of rotating the terminal ray in anti-clockwise direction, let us have the ray rotated in clockwise direction to get a point P4. Now the rotation is in clockwise direction. So angle covered is say B, but in clockwise direction angles are negative. Cos of negative B, comma sine of negative B. So now we will use P1, P2, P3, P4, this coordinates to derive this formula. Connecting P2 to P4 and P3 to P1, we will realize that triangle P2O P4, this triangle is congruent to P1O P3, this triangle. Why so? Why? Because you see in the triangles, OP of this triangle is same as OP2 of this triangle, radius of the same circle. And then angle B plus this additional angle of this triangle is same as angle B, direction, negative is direction only, see magnitude. Angle B plus this additional angle of this triangle. That means this in between angle is added to angle B as well as angle B. So angle P2O P4 is the same as P1O P3. So included angle. So I spoke about SA, SA. And the third side is OP4 of this triangle is equal to OP3 of this triangle. So this vertically standing triangle and this horizontally standing triangle are congruent by SAS, SAS, SAS congruency rule, and by CPCT we will take this distance or this length of the standing triangle is same as this length of the horizontally appearing triangle. Means P2 P4 distance is same as P1 P3 distance as CPCT. So I wrote CPCT. Now what I'll do is I will use a distance formula for this as well as this. Distance formula is what? AB distance, for example, is a root over of x2 minus x1 whole square plus y2 minus y1 whole square. So that square root I want to avoid. So I will write this as, if P2 P4 is same as P1 P3, then their squares are also same. So P1 P3 and here square. So this is left hand side and this is right hand side. Since the expressions when I use the distance formula is going to be too lengthy, so I will simplify first left hand side, then right hand side, and then we will equate. So first we will find the left hand side distance. Left hand side distance is actually P2 P4 whole square. So what is it? It is P2 P4. You see P2 P4. So x1 y1, x2 y2. Here cos of a negative angle, it is the even function. So cos of negative b is actually cos b. Sine is a odd function, that is why sine of negative b is a negative sine b. So this is something like x1 y1 and this is x2 y2. So we will go for distance formula, x2 minus x1 whole square plus y2 minus y1 whole square. So I am writing here x2 means cos b minus x1, that is cos a whole square, plus y2 minus sin b minus y1, that is sin a whole square. Minus a minus b whole square is actually a plus b whole square. We go for a minus b whole square and a plus b whole square for the expansion. Okay, we expand them. So this is a square plus b square minus twice of a into b. So I am writing cos a into cos b. Then plus, this is actually a plus b whole square expansion. So I am writing the condition here because space deficiency. So here we have a square means sine square plus a square plus b square. Both of them positive. So plus twice of a into b. This into this I am writing sin a into sin b because multiplication is commutative. Here you observe we have sine square theta plus cos square theta. So this using fundamental trigonometric identity turns 1. Similarly sine square theta plus cos square theta. This also using fundamental trigonometric identity turns 1. 1 plus 1 is 2. So 2, and then I'm writing this one as well as this one, minus 2 cos A cos B plus sin A, okay, 2 sin A sin B. Take 2 as highest common factor. 2, what goes in the bracket is a 1 minus cos A cos B plus sin A sin B. Sin A sin B. And this happens to be our left hand side. Now we'll find right hand side. Now the right hand side term P1 P3 square. Where is P1? P1 is 1 comma 0 and P3 is cos A plus B comma sin A plus B. So the right hand side is P1 P3 square. If square is there, we can avoid the square root of the distance formula. Now this can be x1 y1 and this can be x2 y2. So we can go for x2 minus x1 means cos of A plus B, this is x2 minus x1 whole square plus y2 minus y1 sin A plus B, this is y2 minus y1, y1 is 0. We go for A minus B whole square expansion, but here only individual will come. Why? Because 0. And then here sin square theta plus cos square theta turns 1, and that one and this one is a 2. So twice, and we are having 2 cos of A plus B. 2 is highest common factor, 2 we are taking out, 1 minus cos of A plus B. Now, since LHS is equal to RHS, we will equate these two simplified results. So let's call this as equation 1 and this as equation 2, and from 1 and 2 right hand sides. So I'm writing this one, 1 minus, okay, 2 is there however, 2 times 1 minus cos A cos B plus sin A sin B. And here 2 times 1 minus cos A plus B. Close. Either sides, the product form 2, that cancels. So let me write one more step. We have 1 minus cos A cos B plus sin A sin B is 1 minus cos A plus B. Okay. So here 1 cancels. Okay, we are not transposing. Instead, we are multiplying negative 1 throughout. When we do so, negative of negative term is positive. So we get here cos A, cos B. Negative of positive is negative. So this is sin A, sin B. Then we have is equal to negative of negative is positive. So it is cos of A plus B. So ultimately we reached or we derived the identity for cos A plus B. Cos A plus B is cos A cos B, this is cos B, cos A cos B minus sin A sin B. Hence this identity is proved. So the first identity in this chapter is cos A plus B, which is cos A cos B minus sin A sin B. Now the second identity is cos A minus B. How to find cos A minus B? It is like, this is something like cos A plus of minus B. So wherever we see B, then we will write minus B to get this identity. So I am rewriting this with only one replacement. It is actually cos A plus negative B. So this is cos A times cos of negative B minus sin A times sin of negative B. Remember, cos of negative angle is cos of that angle because cos is even function, and sine of negative angle is a negative of sine of that angle because sine is odd function. So therefore What is the second identity that we are deriving? It is cos A minus B is cos A times cos B. Minus of minus or negative of negative is positive, sin A times sin B. So this is the second identity. Now the next identity, sine of A plus B. Sine of A plus B, we can write sine theta as cos 90 minus theta. Instead of 90, we are writing angle in terms of radians. So 90 minus theta. Theta is A plus B. So sine theta is cos 90 minus theta. Now this one, a slight rearrangement of terms to get the formula for sine A plus B. So this we can write as pi by 2 negative A negative B. We will put these two as one angle and this is second angle. So we will get here cos of pi by 2 minus A minus of B. Here the pi by 2 minus A is an angle and B is another angle, and we will use cos A minus B identity. This cos A minus B identity to expand this. See, cos A minus B. Cos A minus B is cos A cos B plus sin A sin B. I am going to use that to get the identity for sin A plus B. So I am writing here cos A times cos B plus sin A times sin B. Also we know that cos 90 minus theta is sin theta. So this turns sin theta. And then we have here cos B plus sin 90 minus theta is cos theta. So cos of A and sin B. So the next identity is sin A plus B. What is the formula for sin A plus B? Sin A plus B is sin A cos B plus cos A sin B. So in continuation, let us have the formula for sin A minus B. In that case, what is sin A minus B? To get the formula for this, we will use this identity, but wherever we see B, we will consider it as negative B. Then sin A minus B is, based on this identity, is sin A cos B, but B is negative, plus cos A sin B. So B is negative. So here we have sin A, cos of negative angle is cos of that angle, plus cos A times sin of negative angle is negative of sine of that angle. So positive of negative is negative. So ultimately we get the formula for sin A minus B. Sin A minus B is sin A cos B, plus of minus is minus cos A sin B. So what identities we have learned? We have learned the identity for sin A minus B. Sin A minus B is sin A cos B minus cos A sin B. Then we derived the formula for sin A plus B. Sin A plus B is sin A cos B plus cos A sin B. Then we derived the formula for cos A minus B. Cos A minus B is cos A cos B plus sin A sin B. And these all we have derived from the key formula. The key formula is cos A plus B. Cos A plus B is cos A cos B minus sin A sin B. Now that we have learnt the identity for cos A plus B. Cos A plus B is cos A cos B minus sin A sin B. Cos A minus B is cos A cos B plus sin A sin B. Sin A plus B is sin A cos B plus cos A sin B. Sin A minus B is sin A cos B minus cos A sin B. When plus is here, minus is here, plus. But for sin A sin B, same symbols are there. Same terms before, same terms after. Here also same terms before, same terms after. Now we will derive the identity tan A plus B. Tan A plus B is the ratio of sin A plus B to cos A plus B. And by this time we know the identity for sin A plus B. Sin A plus B is sin A cos B plus cos A sin B. And cos A plus B is cos A cos B. If plus is here, we go for minus sin A sin B. So these two formulas we have already derived. Now what we'll do is, we'll do a common operation. To the numerator and denominator, we will divide with or divide by cos A cos B. Divide all the four terms of numerator and denominator by this. So we will get here sin A cos B divided by cos A cos B plus cos A sin B divided by cos A cos B. That makes the numerator. About the denominator, cos A cos B divided by cos A cos B, same thing. Negative of sin A sin B, sin A sin B upon cos A cos B. Now see, here cos B cancels, here cos A cancels, here the complete terms cancel, and here the groups we can make to define something. So here we get, ultimately we are deriving the formula for tan A plus B. Tan A plus B is, right, tan A plus B is sin A by cos A, means what? Tan A plus sin B by cos B. Cos A is cancels. So cos B is tan B upon this completely cancelled. So 1 negative of or 1 minus sin A cos B is a tan A times sin B cos B, means a tan B. So the identity tan A plus B is a tan A plus tan B divided by 1 minus tan A tan B. So using the same identity, we can derive the next one, that is a tan A minus B. What is tan A minus B? Tan A minus B is every B is negative B now. Since sine, tan, cot, cosec are odd functions, their negative angle is negative of their angle, means tan negative B is negative of tan B. So here we will have a tan A plus tan of negative B divided by 1 minus tan A of tan of negative B. Tan negative B is negative of tan B. This is also the same. So tan A minus B, the formula is tan A minus, plus of minus is minus, tan B divided by 1 minus, this is tan of minus B is minus tan B. So minus of minus plus tan A tan B. Next, cot A plus B and cot A minus B are derived the way tan A plus B and tan A minus B were derived. So cot A plus B is written as cos A plus B by sin A plus B, and then cos A plus B expansion, sin A plus B expansion, and then dividing the numerator and denominator by sin A sin B, we will come across the formula cot A plus B is cot A cot B minus 1 divided by cot A plus cot B, and cot A minus B will be cot A cot B plus 1 divided by not cot A minus cot B, it's cot B minus cot A. So these two formula. Then we have derivation of trigonometric ratios of multiples and submultiples of the angles. So cos twice A. Cos 2A formula is cos square A minus sin square A, which can be written as a 2 cos square A minus 1, if not 1 minus 2 sin square A, and this in turn can be written as 1 minus tan square A upon 1 plus tan square A. So this, how to derive this formula? This formula will be derived from cos A plus B formula, where we will write cos 2A as cos A plus cos A, means B is actually A. So let's derive this. Some of them I will derive, the other one we can figure out that how the formula must have come. So since cos 2A can be written as cos A plus cos A. And what is the formula for cos A plus B? That we will apply here, which is cos A cos B minus sin A sin B. So here B is also A. So we get cos A into cos A is cos square A, sin A into sin A is a sin square A. Then we will apply the fundamental trigonometric identity, that is sin square theta plus cos square theta is 1. In place of cos square theta, means cos square A, we can write 1 minus sin square A, so that this formula turns to be 1 minus sin square A minus sin square A is minus of 2 sin square A. Or in this formula, in place of sin square A, we can write 1 minus cos square A, and then this formula will be appearing in form of 2 cos square A minus 1. And then cos 2A is also 1 minus tan square theta or A by 1 plus cos square this. For that, what we can do is, we can write its continuation, I am saying. So here this is cos 2A, which is cos square A minus sin square A divided by 1. That 1 we can write it as sin square theta plus cos square theta. So I am writing it as cos square theta plus sin square theta. Now we can derive the numerator and denominator by cos square A. When we divide, the numerator cos square A by cos square A is a 1 minus sin square A by cos square A is a tan square A upon cos square by cos square is 1 plus sin square by sin square is a tan square. So this is the formula for cos 2A. On the same lines, we can derive the identity for trigonometric ratio of multiple angles, so sin 2A. Sin 2A is actually sin 2 theta, which is 2 sin A cos A, and this is 2 tan A upon 1 plus tan square A. On the same lines, we can also, how to derive, I am just saying here, sin 2A can be written as sin A plus sin A, and we can use the formula sin A plus B to reach this, and from here we can reach this. Next, sin 2A cos 2A tan 2A is over. Now sin 3A. Sin 3A can be derived using the formula sin 2A plus A. Then we will apply sin A plus B formula to get the formula 3 sin A minus 4 sin cube A. This one I am deriving so that we can figure out how we can derive cos 3A and tan 3A. So for this I am putting a small proof of how to derive sin 3A. Sin 3A can be written as sin 2A plus A, and then this is A and this is B. Sin A plus B expansion. Sin A plus B is what? Sin A cos B plus cos A sin B. B is actually A. Sin 2A is a 2 sin A cos A, and then already we have one more cos A. We have to write everything in terms of sign. So cos 2A can be written as 1 minus 2 sin square A times sin A. We go for distribution. This we distribute over, and here we have 2 sin A times sin A times cos square A. Cos A into cos A is this. Then we get sin A minus of 2 sin cube A. So we see some highest common factor. Okay, we don't want cos actually. So one more replacement, 2 sin A times From first fundamental trigonometric identity, cos square a is 1 minus sin square a. Then we have plus sin a and then negative of 2 sin cube a. We will distribute 2 sin a over the bracket and we will get 2 sin a, negative of 2 sin a into sin square means sin cube a, then plus sin a, negative of 2 sin cube a. Now assemble the like terms. These two are like terms and these two are like terms. 2 sin a plus sin a is a 3 sin a. Negative of 2 sin cube, negative of 2 sin cube is a negative of 4 sin cube a. So the formula for the multiple angle sin 3a, sin 3a is 3 sin a plus 4 sin cube a. On the same lines, we can derive the formula for cos 3a by converting everything to cos, because in sine formula we have everything in terms of sine. So similarly, the formula for cos 3a. Formula for cos 3a is 4 cos cube a minus 3 cos a. How to derive? Cos 2a plus a. Use the formula cos of a plus b. Cos of a plus b is cos a cos b minus sin a sin b, and there every sign has to be converted to cos using fundamental trigonometric identities. Then we have formula for tan 3a. Tan 3a is 3 tan a negative of or minus tan cube a divided by 1 minus 3 tan square a. Now we will have some identities of trigonometric ratios of sum to product, means cos c plus cos d, that in terms of product cos c minus cos d, sin c minus sin d, sin c plus sin d. So here left side same t ratios will be in form of sum or a difference. Right side we will have combination of sin and cos in terms of product. The first identity is cos c plus cos d. Cos c plus cos d is twice cos c plus d by 2 times cos c minus d by 2. So this formula can be derived using the formula cos a plus b expansion, cos a minus b expansion, and vertically adding them once, vertically subtracting them once. We land on this kind of an expression. Now I am not deriving because its applications are more important than the derivation, but derivation as individual videos I will put. That the first one, sum converted to product. Next one, cos c minus cos d is negative 2. If negative is there and both cos, here both sin will come with negative 2. So here sin c plus d by 2 times sin c minus d by 2. Third, sin c plus sin d. Sin c plus sin d is a 2. Sin c plus d by 2 times cos c minus d by 2. The fourth one, sin c minus sin d. Sin c minus sin d is a 2 of first cos will come, c plus d by 2 times sin will go for c minus d by 2. The next set of identities are the t ratios of a product to sum. This was sum to product, product to sum. Product to sum will be exactly like this, but we'll write in terms of a and b. Generally, I don't try to remember this part. I only remember these, and from here I figure out what could be this zone. Like the first identity here is a 2 cos a times cos b. This is something like in this form it is. So here the identity will look like this, and the identity is cos a plus b plus cos of a minus b. The second identity is related to this. So it is negative of 2 sin a sin b, whose form appears like this, which is cos a plus b minus of cos a minus b. Next one is exactly like this, output is like this. So third, twice sine a cos b. Sine a cos b is sine a plus b plus sine a minus b. And the last one is this to this, means 2 cos a to cos a sine b. So this will appear as sine a plus b minus of sine a minus b. Coming to 3.3 exercise. This exercise has good number of questions which are applications of the trigonometric identities that we have derived. Let us begin with this. Prove that, the first bit. So prove that sine square pi by 6 plus cos square pi by 3 minus tan square pi by 4 is negative of 1 by 2. Starting from left hand side, sine square pi by 6. So first, what is sine pi by 6? Means sine 30. Sine 30 is 1 by 2, so it's a square. So 1 by 2 square. Cos pi by 3 means a cos 60. Cos 60, sine 30 are same. So cos 60 is also 1 by 2. And here the square is there, so square. Negative of tan square pi by 4. Tan 45 is 1, so here 1 square. This on solving, this is 1/4 plus 1/4 minus 1. 2 1/4 is 1 by 2. 1 by 2 minus 1 is a negative of 1 by 2, which happens to be the right hand side. So the first one is done. The second one is 2 sine square pi by 6 plus cosec square 7 pi by 6 times cos square pi by 3. This expression we have to prove that it is equal to 3 by 2. So the second equation that we are going to prove, starting from LHS we will go up to RHS since these are proofs. So this is twice sine 30. Sine 30 is 1 by 2, but here square. Cosec square 7 pi by 6. So what we do is, first we'll find this in terms of like with respect to pi or pi by 2, means with respect to x-axis or y-axis, to understand whether cosec square of this stays cosec or not, or plus or minus, whatever. So this can be written as, first you write this pi by 6 and then think about what will you place here so that after this mathematical operation is completed we get this. So I'm just putting pi here. So here 6 into pi, 6 pi plus pi is going to be 7 pi. So a small change here, and I'll come back to this in the next step. And here cos 60. Cos 60 is a sine 30. Means here this is also 1 by 2 and it appears in form of square. In the next step, this is 2 times 1 by 4. With respect to pi, which is x-axis, no change line, means cosec remains a cosec. So it is a cosec square of this angle pi by 6. And where is this angle? This angle is in the third quadrant. In third quadrant, sine only tan and in third quadrant only tan and cot are positive, rest all are negative. So this will become negative of this times 1 upon 4. Now what is the value of this? Cosec is a sine reciprocal. So sine 30, sine pi by 6 means sine 30. Sine 30 is 1 by 2. So cosec 30 is a 2 by 1. So this value is 2 by 1, but square is there. We get ultimately 1 by 2 plus negative 2 square is actually cosec of this angle comes in third quadrant. So its value is negative. So cosec pi by 6 is 2 by 1, which is considered as negative 2 because it is lying in third quadrant. Third quadrant cosec of any angle is a negative. So that is why it is negative inside. This negative can't affect this. And square. So negative 2 square. So this is 4. 4 times 1 by 4 is 1. 1 by 2 plus 1 is a 3 by 2. Then the next question, the third bit. Third question is cot square pi by 6 plus cosec 5 pi by 6 plus 3 tan square pi by 6 is 6. Okay. This is a root 3 square plus cosec. This angle we have to write in terms of pi by 2 or pi. So first we write pi by 6. Minus is better. 6 pi minus pi is 5 pi. So we have to figure out like how to write 5 pi by 6. So this is the way of doing it. Plus 3 tan 30. Tan 30 is 1 by root 3. 1 by root 3 square. This is the left hand side terms, and this on simplification we should get this. So root 3 square is 3 plus cosec of, with respect to pi. With respect to pi means no change. So cosec remains a cosec of pi by 6. And where is this angle? This angle is in second quadrant. In second quadrant, sine and cosec are positive. So this answer is going to be positive. So what it is? Sine 30, pi by 6 is 30. Sine 30 is 1 by 2. In that case, cosec 30 is a 2 by 1. Plus 3 times 1 by 3. The final step, this is 3 plus 2 plus 1. So this is a 6, which is RHS. Question number 4, we are given this expression. We have to show that LHS is equal to RHS. We will be following this conversion for radians to degrees. Starting from LHS, this is a twice sine square. We can write this in form of pi by 4. So first write pi by 4, and you can have here pi minus, because in that case 4 pi minus 1 is 3 pi, denominator 4, plus 2 cos pi by 4 means cos 45. Cos 45 is 1 by root 2 and square is there. So 1 by square root of 2 square. 2 sec pi by 3. Cos pi by 3 means cos 60. Cos 60 is 1 by 2. So sec 60 is 2 by 1. 2 by 1 square is a 2 square. This is a 2 sine square pi by 4. Because with respect to pi, sine will remain sine, and this angle lies in second quadrant. Second quadrant, sine is positive. Plus 2 times 1 by 2, and then here 8. Sine pi by 4 is 1 by root 2, and here 1 by root 2 square will come. So 2 times 1 by 2, which is also 1, plus 1 plus 8, which turns out to be 10, and this is the right hand side of the given expression. Now we go for the fifth question. Find the value of sine 75. So we are supposed to find sine 75. So here this is an application of sine a plus b. Sine 75 can be written as sine of 45 degrees plus 30 degrees, where a is 45 and b can be considered as 30. We are using the identity sine a plus b. Sine a plus b is sine a cos b plus cos a sine b. And we know all these values. 1 by root 2. Cos 30 is sine 60, so root 3 by 2, plus 1 by root 2. Sine 30 is 1 by 2. So root 3 upon 2 root 2 plus 1 upon 2 root 2. LCM of denominator is 2 root 2 and numerator is root 3 plus 1. Sine 75 is root 3 plus 1 upon 2 root 2. So fifth question, second bit, we are supposed to find the value of tan 15. This question is an application of tan A minus B. So this can be written as a tan of 45 degree minus 30 degrees. So tan of A minus B. Tan A minus B is a tan A minus tan B divided by 1 plus tan A times tan B. This formula we have proved in the before video. Tan 45 is 1, tan 30 is 1 upon root 3. So numerator is in this form. We will take LCM. 1 plus tan 45 is 1 and tan 30 is 1 by root 3. So denominator LCM also we will take. Numerator turns out to be root 3 minus 1 upon root 3. Denominator turns out to be root 3 plus 1 by root 3. The numerator's denominator and denominator's denominator go for a cancellation and we get root 3 minus 1 by root 3 plus 1. So we got this, but this should not be declared as answer. Why? Because a denominator has irrational number. Irrational number in the denominator is not allowed. So we will rationalize the denominator by multiplying to the numerator and denominator by conjugate of the denominator. Numerator times numerator is root 3 minus 1 whole square and denominator is a plus b times a minus b. So a square minus b square. So numerator expansions and denominator solving I am doing here. So numerator is a minus b whole square. So a square plus b square minus twice of a into b. So a was root 3 and b was plus 1. On expansion we get like this. Denominator root 3 square is 3, 1 square is 1. Now putting like terms together we get here 4 minus 2 root 3 upon 2. Highest common factor of numerator is a 2. What goes in the bracket is 2 minus root 3 upon 2. We can cancel this. So finally tan 15 has a formula in form of an expression. It is a binomial, that is a 2 minus root 3. Tan 15 is 2 minus root 3. Next, sixth question. We have to prove that this left hand side is equal to right hand side. Cos A into cos B minus sin A into sin B. Cos A into cos B minus sin A into sin B is cos of A plus B formula. Since cos A plus B is cos A cos B minus sin A sin B. So we will concise the left hand side in form of this. So now left hand side. Left hand side's concised form is cos of A. A means pi by 4 minus x plus B. B is pi by 4 minus y. Okay. So pi by 4 plus pi by 4 is pi by 2. So we have here cos of pi by 2 minus x minus y is minus of x plus y. We know that cos 90 minus theta is a sin theta. So this turns out to be sine of theta. Theta is x plus y and this happens to be the right hand side of the given expression. Question number 7. We have to prove that tan of pi by 4 plus x divided by tan of pi by 4 minus x is equal to this expression. We will start from left hand side. This is an application of tan of a plus b and tan of a minus b. So in the left hand side, first I will simplify the numerator and then I will simplify the denominator, then I will put them for division. So numerator is a tan a plus b. Tan a plus b is tan a plus tan b divided by 1 minus tan a times tan b. So tan pi by 4 is 1 plus tan x divided by 1 minus 1 times tan x. This happens to be the numerator. Let's see how the denominator appears. Denominator is a tan of a minus b. Tan a minus b is a tan a minus tan b divided by 1 plus tan a times tan b. This is 1 minus tan x, 1 plus, this turns out to be 1, so tan 45 is 1, and then we have only tan x. Now in the left hand side we will divide the numerator by denominator. That means this divided by this. Its meaning is this times a reciprocal of this, and we see whether we get this or not. Now left hand side in fraction form. It is the numerator 1 plus tan x divided by 1 minus tan x. This divided by 1 minus tan x by 1 plus tan x. So I am just multiplying the reciprocal, which is 1 plus tan x upon 1 minus tan x. Now when we multiply fractions, we multiply the numerators and multiply the denominators. So the numerator turns out to be 1 plus tan x whole square divided by 1 minus tan x whole square. We can take the exponent as common, 1 plus tan x divided by 1 minus tan x whole square, and this happens to be the RHS. Question number 8, we are given that cos pi plus x times cos of negative x divided by sin pi minus x times cos pi by 2 plus x. Starting from left hand side, cos of pi plus x, this angle is in third quadrant. In third quadrant only tan and cot are positive, means this is going to be negative in the third quadrant. But this t ratio is with respect to pi, means with respect to x axis, so that is a no change line. So cos remains cos, so this is cos of x. Cos pi plus x is negative of cos x times cos of a negative angle is cos of that angle because even function, divided by this angle pi minus x is in second quadrant, and in second quadrant sine is positive, so this remains positive, and no change, sine remains sin x, times pi by 2 is the y axis. With respect to y axis or with respect to odd multiples of pi by 2, the t ratio change. So cos of pi by 2 plus x is actually sine. Where is this angle? This angle is in second quadrant. In second quadrant only sine and cosec are positive, rest all are negative. So this is going to be a negative value. Cos of pi by 2 plus x is negative of sine of x. Here the negatives cancel. So here we have cos by sine, which is cot x, times cos by sine, that is also cot x. Cot x into cot x is cot x whole square, which can be written as a cot square x, and this is the right hand side.